don't want to display. It's not sending video. That's good. Okay. Anyway, when do you need this?
Since I can't have my screen, I will be using this to display the chat, but not exactly fine. Okay. Oh, it doesn't even show correctly. But okay, we'll do.
Tools.
Usually agenda because it doesn't show well here. Okay, guys, it's going to be time. So, Thomas, do you want to play the introduction and then I'll take over?
Yeah, sure. I hope you can hear me. Can you confirm you can hear me?
Yes, very well.
Great. Okay, so welcome to the 6TISCH meeting. I'm calling in from Paris. Just finished my paternity leave, so that's why I'm not there. Thank you very much, Michael, for sitting in. So this is the 6TISCH meeting. On the slide, there is a link for the Etherpad. We're taking minutes through the Etherpad. Now, be careful, this link is not exactly correct. It's the one we use usually for interim meetings. For the IETF meeting, it's a slightly different one. But if you go onto this link, you'll see the right link appear. So next slide, please.
Yes, and if you go to the, I thought I had fixed it, it's weird. But if you go to the IETF agenda page, and you look for today for the meeting, there are a number of icons associated to the meeting, and one of them is the Etherpad link.
So next slide, please.
Well, this doesn't work. That's interesting. Well, how can I say? Sorry about this.
No worries.
No, that must be working because it's plugged in.
Well, this has frozen. Let's see if it comes back. See. Interesting.
Okay, now you can do it, and each time you'll unplug the thing in again, so hit slide, and then.
I totally won't. It's really weird.
Okay. So the note well applies to this meeting.
You get it. Works. Okay, go ahead, Tom.
The note well applies to this meeting as it applies to any IETF meeting. If you know of any IPR that we're discussing, whether it's yours or not, you need to disclose it. If you have any questions, go to these links, ask your favorite AD or work group chair. Next slide, please. As usual, we are taking minutes, and I thank the scribes. I see that Dominique is connected to the Etherpad. I see Michael as well. If you go to the Etherpad, please, in the upper right-hand corner, click on the little icon with the three little gray persons and put your name. Simon will just connect it, thanks. So we're taking minutes, we're recording the minute, and all of this is published to the mailing list right after the meeting.
And this
Next
is,
slide,
by the
please.
way, the correct link for the Etherpad. That's why I fixed it.
Yeah. Yeah.
Right, so this one works. Let me take over, Thomas, maybe.
Sure.
So, sorry.
Blue
Yes,
sheets are
we'll
coming.
wait 5 more minutes before we circulate them, just because people keep coming. So it's kind of habit we have. You know, radios are slow. So we actually have a very long meeting this morning. We have 2 hours and a half. So we wish to take advantage of that time to do actual work, not just present status of work and group documents, etc. So in particular, because it's a huge topic for us, we have 70 minutes dedicated to the work on security And this is when it's very practical to have Michael sitting next to me, because he will be leading that piece of the agenda. After that, we'll go through the 6TOP protocol. And since Xavi could not actually join because he's somewhere in Europe in a place where the firewall won't let him connect, so Thomas will actually present for the 6TOP protocol. Then we have Diego here, who will give us the updates on the service function 0. I'll give you some updates on the architecture. It's rare, but there were some additions, some work done on the architecture as well. And from there, Pat kindly will let us know what's the news from IEEE 2015-4. And then we'll have an interesting presentation coming from the work done at .NET. So Loon will be coming and presenting us something that he presented yesterday at .NET about how you can architect a network which has not only some 6TISCH components in it, but also a backhaul, say an Ethernet backbone, which could aggregate them in a deterministic fashion. Diego?
Diego from Universidad de Portales. It's not service, but scheduling function.
Oops.
Something. Thank you.
Oops. Okay. And with this, we'll just check if we have our volunteers. So I didn't know for Francesca. Is Francesca with us today? Are you willing to help us as well, like you did last time? Thank you so much, Francesca. And then, well, yes, there is of note taker that we kind of got committed. Xavi won't be able to join, but please join this. But anyway, just that helps if you don't understand all the words which are being spoken. Sometime a note is taken, which will help you anyway. For Jabber, we have Ines and Michael. Oh, all said then. And with this, I will, since Xavi is not there, I will be doing it. So, and I'm happy that Suresh joined us, because it's even better. Suresh, I saw you coming. You left? Oh, bad. Okay, so the minimal draft has stayed a long time in the ISG review process, and in particular, there was work to be done on the security aspect, but not only. And Xavi has finally considered all the reviews and solved all the issues. So my best knowledge is that draft 21 is the one going to be published, but for the RFC editor changes. So now I would have liked Suresh to confirm, but the draft is going to the RFC editor. It passed IANA for the last thing I saw. There is nothing much to do for IANA anyway, but that's a step, and that step is passed. Considering our milestone, we are a bit late, as you can see. So we have done a number of our commitments, but we should be shipping 6TOP and SF0. We should have been shipping them for like a few months already. So I think it's high time we do, and that's going to be the core of discussion on those documents. Are they ready? Is there something missing, and what's next? And with this, we'll start with the update on security.
A question, Pascal, is there plans for future plug fests?
So maybe I can answer.
Yeah, go ahead.
Yeah, so there is absolutely plan for a next plug test. We are aiming for having one the weekend before the Prague meeting. So that would be, if I remember correctly, that would be 14th and 15th of July. We're starting to make practical arrangements with the IETF and the hotel there. It would be 14th of July afternoon. Let me, if somebody sees that this is not the right dates, let me know. But this is the weekend right before the IETF. So 14th of July and 15th of July, 14 afternoon and 15 all day. So it would be the same format as we usually use, meaning we would set up a team of experts that would write a test description and have the tests follow that test description. There's one kind of exotic thing. The idea is to use some online tools, some tools to do online testing that are being developed through a rather big project called F-Interop. And so it would be a physical meeting, but we would be using tools from that project. So mark your calendars right before IETF meeting in Prague. And I propose, Pascal, that at the next interim meeting that we discuss the scope of the interop. Given, I mean, we'll go through it today, but given the state of the different drafts, I think minimal security are certainly candidates for being considered. The 6 protocol is very stable as well, so those seem like a good bunch. But we'll have to discuss it, and I propose that we do so in the next interim meeting.
Would we want to take that opportunity? This is Carrie Lynn. Would we want to take that opportunity as well to have a 6-low plug test? Is there sufficient space for that? Probably just
well, we can discuss that tomorrow. 6
Okay.
low is tomorrow morning,
Okay.
but yes, we'll have that in our mind.
get that out there.
And I saw that Suresh came in. Suresh, we just discussed the status of minimal 21, so you're the one who knows best. Can you?
Yeah, so this has been a difficult draft. So 6TISCH Krishnan, so it's been a very difficult draft, and it's like got like a lot of review. So I'm very happy that it got a lot of review, and thanks for the authors. And we've been through quite a bit of revs on this with like some major changes. So I think it is like it's gone really well at the end. So like we had like a couple of discussers, and everything got turned around very quickly. And thanks for like Tero as well, if he's in the room. For the SecDir review. So that kind of really helped, like, setting the tone for the security issues in there. And yeah, so let's look for other documents from here. So thanks.
But the status says it's going to the RSA, right? That's the status. I have. Okay. So Michael,
Yeah, it's already there according to the tools page.
So I approved it just before the meeting, like probably a week ago, I think.
Hi. So I'll stand in the box. So Anima and DetNet were scheduled yesterday afternoon. I'm just curious, how many people were in DetNet? Not that many. Wow. And how many were in Anima? Also not that many. So more than half the room was in neither DetNet nor Anima. So I don't know what you're doing, but something else. Obviously something more important than 6TISCH work, but there you go. Okay, so the part of these slides are aimed at the assumption that you didn't sit through Anima and aren't familiar with that. For those of you that are, I'll ask a little bit of patience if you have any disagreements or if I've misstated things to hold it till a little bit later, because I think it may be a little bit. I may come back to that point, but please don't hesitate to correct me if I have overstated or misstated something. But my goal is basically to give you, first of all, an overview of what went on in the interim meetings, on the design team meetings rather, they're not interims, and what the overall plan is. And then we're going to kind of deep dive a little bit into the individual drafts. But before we go to the individual drafts, my goal is to explain how the drafts fit together, or how we intend them to fit together, and they don't exactly fit together yet that way. So the design team met every 2 weeks, approximately, with a couple of cancellations and some extra meetings added. There were a bunch of people that did volunteer for the design team some year ago or something like that when we formed it a year and a half ago. I would love to see some of those names that, if you did think you are on the list and didn't come to the teleconference, I will be putting up a new doodle poll to pick a new time. I know that it was very inconvenient for people on the Pacific Coast, but on the other hand, we're trying to accommodate people in many time zones. So I'm going to be putting up a new doodle poll and picking a new time, and that's essentially the goal is going to be to meet about every 2 weeks by WebEx or Jitsi, or I hope not WebEx, because I'm tired of it continuously changing. It worked so wonderfully, and then it stopped working for me completely and stuff like that. So that's was the goal, and typically those people were present, and actually I think Pat, you joined us a few times. Maybe did you? No, never. No. Okay. So what are we doing? We're working group will continue to work on securing the join process and making that fit with the constraints of high latency, low throughput, and small frame size that characterize IEEE, blah blah blah. So another way to look at it is that Roll was told, for instance, to please secure industrial networks. and an applicability draft was created, and it was quite big, and it had a lot of, you know, 2BDs, TBDs, TBDs, TBDs. And in some sense, this whole working group was formed out of the need to fill in those TBDs. Okay, so at the end of this conclusion of this working group, you can almost consider that we will have produced the applicability statement of role to industrial networks, plus a whole bunch of other stuff that are necessary. And actually, I'm probably going to write that applicability statement. I don't know if we were publishing or not, but it might just be nice for the roles completeness to do that. Let me see. I hate this because it doesn't work for. Let me see. Push. Is there a button to push the laser? Is there a laser? Oh yeah, there is. Remote people, Chris, can't see this. So RC 7416, which is security threats to role, but actually applies generally to all LLNs. You know, produces this business of industrial applicability statement, and then to the 6TISCH work. So that's why we're doing this. Yes, Peter.
Peter van der Stok, a bit slow, but nevertheless, we look forward to receiving this applicability statement. Thank you very much.
So well, it's just, you know, it's got a checkbox that was never checked. You have to do it all. So the draft. So last meeting, we discussed 6TISCH minimal, which was an attempt to basically do a one-touch security that would be scale within certain boundaries, and this was added to the what had been the design team work up to that point, which was to do a zero-touch thing, which was designed to scale into the very large and the unattendable or devices that you just don't want to touch. You can't open and do something. In the process, 2 new drafts are created, which are going to be discussed today and perhaps adopted. Oh yes, when we adopted these in December, just after the last IETF meeting, if I'm correct. And so it created 2 drafts that we pulled out of them. One was about rekeying the networks, and the other one is about enhanced beacons. The enhanced beacons document, if 6TISCH minimal itself was still very delayed, might have been folded into that. So this one's intended as a standards track statement, and we'll get into what they do afterwards. So one of the things we did is we tried to reconcile the terminology between netconf, anima, and 6TISCH. And so we had a bunch of different terminologies for the different kind of roles that we think, and we agreed to basically coordinate them. Okay, so that means from our point of view, the joining node, there were arrows here at one point. The joining node becomes the pledge. Okay, and if you've ever watched any of the bad sorority movies, the pledge is the kid that, you know, the sorority decides to, or the fraternity decides to, whether they're going to adopt or not, let into their clique of people. And they may have to go through certain hazing or other rituals before they get to join. Okay, and so that's the term that we used. The join coordinating entity was that term. We had picked it in analogy to the path computation engine. So we'd have a JCE and a PCE, and we'd understand they were both a centralized thing. And so we've changed that name to the join registrar and coordinator. Coordinator because it's probably going to be handing out 2-byte addresses and some other things. Finally, what we have called the join assistant, others would prefer to call the join proxy. And so while they've taken our term, some of our terms, we're taking some of their terms, and so we're going to call it the join proxy. So that sort of summarizes it a little bit more with a little bit more diagrams. Some of the other items that come from Anima is we have the Manufacturer Authorized Signing Authority, or MASA. And the reason why we use that big term is that essentially we want to make clear that this is the manufacturer who designed and built the device and has had privileged access to the innards on the factory floor. But the reality is that probably many manufacturers won't really want to run this themselves. They will actually want to delegate it and outsource it to somebody else. And maybe there will be companies that whose whole business model is that they provide that service. And so we want to make it clear that it's probably not the manufacturer, but it is something who's close enough to them that might as well be them. Manufacturer may install a certificate, a manufacturer installed certificate, or they may install a pre-shared key. Okay, and that happens on the manufacturing floor probably, or in some other privileged environment, JTAG cable, bed of nails test. There's a bunch of different ways we can imagine it. It's not our problem. Point is, manufacturer put something in there prior to shipping the device. If they put a PSK, then they actually have to know really who they're shipping the device to. And in some cases, for some manufacturers, it's a standard procedure right now, is what I'm told. And the customers essentially are given a SKU number. Your devices are SKU number 1, 2, 3, 4, and someone else's are 1, 2, 3, 7. It's the same device, but yours has your PSK and the other one's has someone else's PSK. Ideally, those PSKs are actually unique per device, but we're not saying anything specific about it, but that really is much, much better. So that goes into the pledge, which is the P, and there's some production network, A, E, and J, and I conveniently labeled the joint assistant, which I didn't change the name again, as J, and then this is part of the other mesh. And then at the top here, we have the joint registrar and coordinator, and it could be relocated at the DODAG route. It might not be, it might be elsewhere in the network, and there's some complexities if it is, but there's no conceptual problems with it being elsewhere. And then finally, we have something else that comes from the MASA to the joint registrar, to the owner of the device, and that's either an ownership voucher, which is a digitally signed artifact that says you own this, or it may be a USB key full of PSKs in an Excel file or something like that, right, per vendor, CSV file, something like that. So I wrote a decision tree that I think of as what's supposed to happen when the pledge power's on. And it, basically amounts to, well, do I have keys for this network already? If I do, hey, I probably have some timing information, and I can capture an enhanced beacon at the right time, and I'm all good. And if everything's good, have they expired, or did I miss the beacon? Did I not find it at the right time? If that's not the case, then I'm just good. Hey, I booted up. I've already been joined. Everyone's happy. Good, good, good. Let's go. Otherwise, you need to basically listen for, and you have to find an enhanced beacon. That's one of the things we wound up discussing in the join in the process, is that, look, you can't get on the network until you find the network. So you actually may have to stay awake, and there's some large discussion that we could have about how long and exactly how do you find the right channel and the right time, because as time, slot channel hopping, you have to listen for a while on potentially quite a few channels, maybe for several seconds on each channel, to hear an enhanced beacon. And when you do finally find one, it tells you what the rhythm is for everything else, how often you should wake up, which channel you should listen to, and when you're going to be able to synchronize the network. Until you do that, you're kind of stuck, right? And potentially realize that this potentially could take many, many minutes, and this may be many minutes when you have to be on with your receiver on. So that may be a really big deal, okay? And if someone has a brilliant idea to avoid this, to synchronize the clocks, from God or something else, that would be great, but we haven't found one yet, right? But you got to do that. And then there's the potential that you might hear an enhanced beacon not for the network you're interested in. How do you know? Well, you might know already because you have a PSK or something else that has something that tells you this is the network that I'm looking for. But if you're a zero-touch device, you also don't know. And so, you have to go continue on. So do I have an IDEV ID? In other words, a manufacturer installed certificate. And if I do, then I should run zero-touch. If on the other hand, I found my PSK or some other, or a raw public key provision, then I can run 6TISCH minimal, the one-touch operation, and I go to normal operation. So having a raw public key is very similar to having a pre-shared key. It's a little bit safer because it's you don't have to worry about disclosing it, and the private part stays private. On the other hand, it has no statement as to who you are, right? So you still basically, the owner has to prearrange to know who you are. So there's some potential compromises, it's not security compromises, but operational compromises between three different possible things. So I tried to make a list of constraints that we have, and some of the responses that in the join process that we had. So the idea was that this column was constraints and this one responses, and I actually would be interested in if you have some more constraints that I haven't thought about or things that we're doing and why are we doing them, okay? And I think that would be worth filling in, and that sort of open mic discussion if you have some more things to add. So the 1,000-foot view, I've been through a bunch of this, but I'll go into detail. A joint assistant, you got to listen for a beacon, okay? You must scan all the channels. You might not be short. If you get to do the 6TISCH minimal with the PSK, then you're looking at essentially a join request, a join response, and you're done. That's it. Very simple, very quick. You still have to do it through the traffic has to still go here, 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 coming back. And because this guy is not part of the network and doesn't have an address, he's using linked local addresses, this joint assistant has to do some kind of a stateless proxying. We've had a lot of conversations about exactly how to do that. We're going to get into that. If you're doing raw public key or you have a certificate, then you have to do a different operation first, which is to set up using ad hoc to set up the OS CoAP, if we're going to use those, scenario. That's a three-way thing. If you were at ACE yesterday, then you heard Joran talk a lot about some of the attributes of this thing, and I probably used an old diagram. But the important part is there. And there's also, we had some discussion about reversing this. So party U would usually could be the pledge, but what if party U is there? So there's potential to think maybe we should reverse this flow. And it was pointed out to me that one nice thing is that we can actually put another message in here to do some bandwidth management in the middle. I'll get into that later. So the proxy mechanism. So, well, we have some challenges here. We have two ideas. One is that we can use IP/IP. So essentially, if you're familiar with how non-storing mode in Ripple does, we put an IP/IP header and we put an RH3 header to do source routing, and that's an IP/IP thing. So the proposal is add one more IP/IP encapsulation, and inside of that, put link local addresses that reach the pledge. So you basically address a packet to the join proxy, and then it decapsulates it and sends it on the last hop. Potentially, yeah. Yeah, sure, you could start now, but we're going to come back to this, but this will be a good time too.
And I think Thomas is on queue as well.
Oh, okay, yeah, let's do that.
Yeah, not this one. I think in your flowchart, I have one very quick. This is Subir Das. I think that if that last box, the pledge has device ID no, that does not mean that it's a loop, correct?
If the pledge has no IDEV ID,
that means it goes
then
again it will go its loop.
Then it will go back and listen for a new enhanced beacon.
Okay.
And the reason is because potentially the reason to go back there is because you didn't find an enhanced beacon for which you had a credential. So you have to go back and listen for more.
Right. So,
Okay.
So is it that underlying assumption that the pledge has always have either of these two credentials? It cannot have, like, I cannot buy a device from Best Buy and then try to join, right? It has to have something on it.
If you bought it from Best Buy, then the manufacturer put something in it.
Okay.
Okay.
Fine.
And how you found the rest, how you got the rest of the credentials to claim it,
right,
is a discussion, as a whole discussion, and
Sure.
that's a lot of what Anima is about, for instance.
Okay. No, I know, for example, my use case have always that thing because the manufacturer has either the pledge or the coordinator, and then when they deploy that in a pre-configured something, right? That's
Right.
fine.
So if it's a vertically integrated manufacturer, it's easy, right? And
Right.
but of course we're trying to enable.
Yes.
multiple
all other
vendors.
cases.
Yes.
Exactly.
Yeah.
Okay. No problem.
Okay. So let's go to Thomas.
Yes, Thomas is next in line.
Thank you. On your, you said, Michael, something about the time it takes to join. I just want to make sure that that the right message goes through. You can optimize many things. You can optimize how many channels you listen on. You can optimize how many channels you send on, etc., etc. In the stuff that we've been doing, with a very conservative numbers, it's it's a handful of seconds you wait, or maybe a couple of tens of seconds, but it's not minutes. And then you on your slide 8, you asked for constraints. There's one example that I like using, in particular with joining. It's imagine you have a factory floor, you deploy 1,000 modes on there, and then the last thing you switch on is your LBR, your root of your network. How long does it take for all the nodes to have joined? And so I think one of the constraints is also that people can deploy it in such a way that you have a flood of joins.
Yeah, okay, so that's
see what I
worth
mean?
adding to the list and figure out what our response is and that kind of thing. The reason I want to include this is because sometimes our motivations for why we're picking solutions is not obvious to people coming in. Well, why are you doing that? We say, oh, because we have 1,000 moats that go on at once. Oh, yeah, that would be bad, right? Sorry.
Thank you.
So is that enough, Thomas? Are you done? Yeah, okay. Hi.
Hi, Benjamin Dam. Did you cover in your flow diagram there? Did you also cover the case where the device attempts to register? Sorry, I'm using language that I'm used to, so it's a bit of a language switch for me.
Go ahead.
The device attempts to register with a certificate that the upstream registrar decides is not valid, and then that's why you go back through the flow again.
Could you bring that question up on the list? Because I think it is a very difficult question as to what to do. One potential answer is that the operator of the JRC is not yet happy with the device. And the example is that I think of is some devices were shipped out to the plant in Missouri and the plant in Arkansas, but they were swapped, right? So the new valve controller for the plant for Missouri is in St. Louis. And it comes up and it tries to join, and the guy looks at his thing and says, I don't know what this device is or why it's in my plant, but where's my controller? Okay. And something comes up to humans, and after some communication, like on the phone, they realize they have the wrong device, that the shipper made a mistake, but it's okay because it's the same part. And so there is some adjustment to the management station that says, okay, I have serial number 4 and you have serial number 7, and we intended to have the opposites. Okay, I'm going to do the whole thing and I'll swap it around. And that could take a whole week of looking through supply chain records and who shipped what and why is it here, and is this the right part and can we use it, and in the end, the network, that device boots. And you can imagine, it's sitting there for days wondering what's going on.
Great. Well, I'll
Yeah.
bring it to the list.
Yeah.
So Michael, you're at the end of this slot, so
Pardon me?
you're at the end of this particular slot.
Yeah.
So.
Yeah, I am. Yeah, that was the last one. Then we're talking about IP. So IP is one. There are some benefits and some downsides. What we're hoping, and we don't have existential proof in the form of code yet, that 6LoRH, which we've created in Roll to compress all these lovely IP artifacts into 1 or 2 bytes, we'll be able to compress this additional IP header as well, and so it will be relatively cheap to do. Alternatively, we have a CoAP mechanism that's proposed, and this keeps it also stateless by essentially adding a header as the traffic goes up from the joined proxy up to the JRC that essentially says, this is how you send it back. And the reason why we want to keep it stateless is because we do not want to have an attack on the join proxy cause it to run out of RAM, and it's probably got very little RAM to begin with. So we don't want to store any state at that edge. We want to move all that state to the JRC, because it's presumably is a capable machine that can deal with the problem. The downside is that we may burn network bandwidth proxying an attack through the network. On the other hand, 6TISCH is all about constraining and controlling use of network bandwidth, so that shouldn't be a problem, should it, right? So as I said, one notion about the case where the device is the wrong thing is we might have an ACK here that says, yes, I heard you, I'll get back to you, okay, a few days later. So that's one of the parts of that I mentioned already. Okay, so I think, are we going to do militia right now, or do you want me to continue right now?
You were first, and then Manisha was.
Yeah, I thought we should reverse it, but I guess you didn't hear that message. Okay, so the document IETF 6TISCH DT secure join is started as a fairly large document sometime maybe more than a year ago. And with the introduction of the minimal mechanism, what we're trying to do is essentially to reduce this to just the scope that deals with the zero touch. So in the last few months since the last IETF, we've been trying to shrink the document, pull text out of it, and put it in either 6TISCH minimal or other documents. Yeah.
Thomas said if we are going to have an opportunity to talk about IP and co-op.
Yeah, when would you like to do that? He wants to talk about IP and co-op versus co-op. Yeah.
Well, we'll see what we are.
Yeah, let's take that at the end if that's okay, Thomas. I agree, it's an important thing to discuss. Yoran has suggested with the introduction of 6TISCH minimal has come along OS co-op as a key management rather than DTLS, for instance. And then one of the proposals is EALS, which I can't remember what it's called now, enrollment, something secure. That's essentially a way to mix all of the enrollment processes that Zero Touch really needs into the key agreement protocol or into parts of it. And so that's been the goal. So other pieces are is that's a very important thing is that this document assumes a Anima-like or Anima voucher artifact. So that's a signed object that says that device X is owned by owner Y, and the format of that would ideally, for our point of view, be in a constrained format, such as, for instance, CWT, which is the CBOR equivalent to JWT, which is the JSON Web Token. So you go up to the web space, you have these lovely signed artifacts that are used in OAuth and other things like this that express similar concepts. You know, party X is allowed to do Y, signed by party Z, right? In this case, it's, you know, this device belongs to you. You're allowed to own it. And so it translates back nicely into from the CBOR people. They have basically taken the JSON version of this, which was signed, and created a CBOR version of it, which is signed with COSI. So that would be very nice because we already have CBOR in our protocol, in our protocols. We already have it in our stacks for lots of things. And if you're doing anything involving ACE, you probably already have COSI. So that would reuse the maximum amount of code, and OS co-op is of course based on that process as well. So it would be nice if we could just use one set of cryptographic and signed artifacts. On the other hand, from the point of view of Anima and NetConf, introduction of CBOR is a new technology to them, and they would be and they don't have any of the constraints that push them to have to adopt new technology. So that's a negotiation that we have to have back and forth, and it's a friendly negotiation, and we essentially may say we're going to do it we may do it in COT, and that Anima voucher format 2 will be COT, and it doesn't have to be mutually exclusive or win. So yeah, so I probably covered a lot of that already. Brewski, that's EST, it's similar concept. I talked about the vouchers, EALS, and ad hoc co-op. We talked about that. So this is a document from Anima. Max, I think we lost some red boxes along the way. Yeah, so there's some boxes here. I don't know what happened to them. But this is attempting to basically make it clear that why we don't particularly need to concern ourselves with concepts of revocation and this kind of stuff. The discussion yesterday was mostly about do we need to be able to revoke if I give you ownership of a device and I give you a 10-year or infinite artifact, do I need to revoke it? And the alternative is that you'll get a voucher valid for online, you get a voucher for 20 minutes, and at the end of the 20 minutes, if you haven't claimed the device, you should come back later. So that's the idea at the bottom here, that you could just get a new voucher for the time you needed it, and then you didn't have to have a valid one while you weren't trying to enroll the device. So that's a detail. I don't think I want to get too much into it. You have something to add, Max?
This is Max. For one, you can find this in the notes for the Anima call, so the uncorrupted slide is available there. The only important part to get out of this is that the green arrows are the only part that was really important in the top two choices, and so the bottom choice is to say, let's just use those parts.
Right.
Yeah, Suresh Krishnan. So like, there's something like higher layer question here, right? So regarding the one touch and zero touch stuff, right? One thing that concerns me is like having like two different mechanisms. Like, so what do you think is going to be the uptake of like one versus the other? Like, is the zero touch going to be adopted by everybody or like nobody, like, or like somewhere in between?
So I think that we will have devices that may ship with both of them capable. The goal is, my goal is to make the on the wire mechanisms be as close as possible, such that what it really amounts to is you do, because we and this is more visible in I don't have a really good slide that this is perhaps the best one. So this is really, this would be the zero touch enrollment, okay? And this is the one touch enrollment if you're using raw public keys, okay? So you can see the difference is this single ACK.
Okay.
All right, and the reason for this ACK is essentially having to do with bandwidth management. One of the reasons, one of the other differences that is that one of the other areas to discuss the differences is who initiates the process. Does the pledge initiate the process and drive it? That is, does the pledge retransmit on the pledge's schedule? Or does the JRC drive the enrollment and it initiates and retransmits on its schedule? And on the pledge's point of view, it somehow looks simpler if the pledge initiates and does all the work. On the other hand, if you look at the network congestion issue, all right, you have a lot of pledges, 1,000 have just turned on. Well, they're not all going to get the very small amount of bandwidth through it. If the JRC manages this process, then it can essentially bring each pledge one at a time through the process. That could take many minutes to even hours, because you have to send X many bytes to X many devices over a channel that we've only allocated, 2% of a, 250 kilobit channel total. So if you just look at the bits over the wire, it takes a long time. And that may be acceptable. And the answer is, if you want it to go faster, give it more bandwidth, right?
Right. Like, so, but at some point, somebody still has to pick between these two, right?
So
where do you see that happening?
So the way I see it happening is that if you have a close relationship with your manufacturer and they're willing to put PSKs in for you and give you your own SKU, that you'll be better off with minimal, because it's faster and simpler. But you better have a close and long-term relationship with that manufacturer, and the number of devices that you're going to deploy probably is going to be moderately large, not very large. Okay, if you have a very, very small number of devices, then the overhead of some of the relationship with the manufacturer is probably going to be too expensive.
Mm-hmm.
So then if you have a small number of devices which you buy from many manufacturers, or if you have, as the example was Best Buy, right? Or you have a very, very large number of devices, then you're going to, I think, want to go to zero touch, because you're simply not going to be able to manage this many PSKs. And then there's the concern. I mean, there's, I think, a real concern that the PSKs are going to come out all zeros, right? That the randomness that was supposed to go in the manufacturing floor might not happen.
Thomas said that you can have as well a configuration step.
Pardon?
Thomas said that you can have as well a configuration step.
Yeah, so the one touch essentially implies that there is at least one specific operator-specific touch. So that's, for instance, you may not install the PSKs in the manufacturing step. You may accept all the devices into your provisioning lab where you hook up a JTAG cable, right? And if that's something you can do, then great. Hook up the JTAG cable, put it back in the box, ship it back out. And I see, people saying, no, it's not going to work. But yet But yet, Carrie, there are people that think that that's a reasonable process, because for the scale of the devices they want to deploy, that's okay.
Right. And so, like, my question still remains. So somebody still needs to pick between these two, right? So I'll just provide an alternative. I don't know if this is going to work or not, right? What if we have one mechanism with like mandatory pieces and optional pieces? That's why we have like different requirement levels. Is it possible to restate these two as like one thing with optional pieces?
I would say that that's what we're trying to do. Okay. We're trying to build one protocol that basically says, if I have this optional piece, then I can do this additional thing. If I have this PSK, which matches the network, then I can do the simpler thing. And if I have this IDEV ID, then I can do this second thing. And it's, if you have neither, well, you're screwed. You can't do anything. Okay. That's not an option. If you have both, then it could very well be that, you know, you have a PSK for network A, but if you happen to be deployed on network B, that's okay, because you have an IDEV ID and you can do the rest of the process, assuming network B was ready for you. And if it wasn't, well, then there's some error, and I don't know how we're going to, you know, how we're going to blink an appropriate LED or something to say it's broken, because there may not be an LED.
Okay. So the concern I have is, right, is like, so we saw this in softwares. Okay. So there's like a bunch of mechanisms. Okay. They're all like very similar. They're like, let's say 90% similar, to be very frank, right? And then there's a small piece that is different. So like somebody who's like doing this like in a most, let's call it minimal way, like for like a lack of a better term, would probably implement these separately without like thinking about the commonalities between these. And the way the specs are written today kind of encourages that. That's how I see it. Okay.
And we're trying to get away from that point. And I thank you for bringing that. I think we're trying really hard to get away from that. I think part of the difficulty is that in the process of pushing this together, we have some really good, interesting proposals from, for instance, Johan, about essentially changing our core underlying security protocol that's common to both of them. And that proposal looks really, really good, but it doesn't really have a home yet, right? Okay. So it's hard for us to be sure that we're going to be able to point to it when it doesn't even have anywhere to go at this point, and there's lots of pushback as to why do we need it at all.
Okay, sounds good. No, I just want you to be conscious of this when you develop this further. So
yeah, what's our time like? I'm sure I should go faster somewhere. Open issues. Does the voucher still need to support indirect issuer? So that's the concept that when I tell you who your owner is, I could tell you by directly by linking to your public key. Here's the public key that's going to own you, and if bad things happens and you get a new public key, or you just roll it for cryptographic reasons, then you'll need new vouchers. Alternatively, if I give an indirect method, then I wouldn't say public key XYZ. I would say, you know, verisigns example.com, right? And so there are advantages and disadvantages each way. And the catch is that if I say verisigns XYZ, then that means that you're doing WebPKI stuff in your pledge, where you didn't want to do it, right? So that's a catch. Do we need to support revocation of the domain certificate? So that's the corollary of the whole thing. PKCS7 or something else like CWT. I don't know why all the numbers are 1, but it should be 1 to 4. And is there a need for authority key identifier? That was some of the anima issues that about the vouchers that come up. Other issues about this, we would like to here. I think we would like to do CWT. CWT is not yet a good match for the general community. CWT is a really good match for our community, and so one of my calls to you guys in the room is to please, if you could help me articulate why you want to use that, or why you would want to use that, and what libraries or mechanisms or savings does it represent for you over pulling in, say, PKCS7 into your pledge, which I'm scared of. I don't want that code there. And Anima suggested we should, perhaps we just need to revise it. So I took those slides. So one of the issues is in this is when we initiate, we'll see that there is a bit in the enhanced beacon we've added, which basically says at this point, should the pledge start and transmitting, or should the pledge just basically send some message that says, I'm here, cryptographically, probably unsigned, and then wait for the JRC to contact it. So that was the stuff I alluded to earlier as to whether or not you're going to initiate the connection or you're going to just passively wait for it. And so the network could announce to the pledge which mode it's going to be. Now, generally, we've thought of in the zero-touch case that you're going to always wait, and in the one-touch case, it's a smaller system, smaller network, you're going to initiate, but that's not, no reason that has to be attached that way. We can make both choices in both directions. And so the network could announce in the enhanced beacon, it have a bit that says, hey, I want you to initiate, I want you to not initiate. If you don't initiate, then one of the questions is, you still have to say you're there. So in the original document, you said, essentially we did unsolicited DAD, basically neighbor unreachability, duplicate address discovery message, and based upon that, that told the join proxy that you existed because it either answered that you were unique or not, and that was it. Another possibility is that we do the first message of the OS CoAP exchange, and we would have to put the pledge's identity in there because actually Sigma I is designed to keep the initiator's identity secret, right? That whole mechanism. So we have to put something in there. It doesn't actually have to be the pledge's real identity or its full identity. It could actually be a hash of identity because the JRC could also run hashes on the identities it knows about. That would be a possibility. So there's some discussions there as to what to do. How to carry the voucher. So EALS has, do we have a way to pronounce that, Yoran? Eels, like the things that swim in the lake and shock you. Okay. For a hilarious thing, asked Christian Huitema about what Torito used to be called, right? So one possibility is that you go and this is what Anima Brewski does, is you go and you create a secure channel. But since you don't know whether this is the network that the pledge doesn't know whether the network that it's talking to is really the correct network, it must provisionally accept the domain certificate from the join. So basically what it means is I've accepted it, but I haven't really verified who he is. And then within that secure channel, you would transmit the voucher, which would then link correctly to the certificate you previously received, and everything's happy. But that's 2 steps. One advantage about making it 2 steps is that you separate the cryptographic operations into one library and the voucher certification another part. It's perhaps a little bit easier to think about the 2, and there may be some advantages in network bandwidth in terms of you may have more messages, but they're smaller messages, and so they're easy to get through. Less use of CoAP block mode or spread over more places, so there's some advantages. On the other hand, we could actually have the voucher transmitted essentially as with the JRC's identity within the security protocol. It's essentially a kind of certificate chain anyway. So we could have that, and that would eliminate the need for this provisional state, and that would be great. But it does mean that the whole process takes longer. It also means that during the setup of the secure channel, the domain registrar, the JRC, needs to know the identity of the pledge first. So the pledge can't tell his identity after the channel is created. He has to tell his identity before. And if you know the difference between TLS 1.2 and 1.3, that's one of the things they fixed in TLS 1.3 is that you no longer have to reveal your identity outside of the secure channel. So we would actually be going backwards a little bit in terms of privacy because the pledge would really have to say who he really is before he has any idea who he's talking to and before he has any security attached. Now, Yoran probably has a brilliant solution that gets us all of those things at once, but so far I don't think it's written down yet. So this was a proposal, for instance, of how some of the stuff could work if you basically are mapping straight EST messages onto CoAP, and this might be a lot of what, say, for instance, CoAP, EST over DTLS or EST over OS CoAP might look like. That's an example. I made this up. It's not the only way of doing it, but if you don't transmit if you try to do straight Brewski over this is what it would look like. And there's a bunch of things. And there's some things we can probably collect together into into fewer round trips. But fewer round trips also means larger messages. So you take your choice of what you prefer. Ideally, we would use ad hoc and OS CoAP for key agreement. We'd have a common voucher format across all working groups. This would enable the JRC and the mask components to be common between NetConf, Anima, 6TISCH, and anyone else who uses this similar mechanisms. And I think that's important because essentially I think there's an industry that will be created to support that, and that's good. The choice of zero touch, one touch is orthogonal to the question about bandwidth management. So I think that networks are going to want to decide one way or the other. In some cases, they may be like, yeah, everyone just connect. When you turn on, just connect. And then when it reaches the bandwidth limit, you start saying, no, hang on, slow down, right? So there may be some advantage to doing something like that. I would prefer the IP-IP mechanism. I would like Anima to offer it as well. But that's my preference. So that's my choices. Now would be a good time, Thomas, if you want to talk about that, but I think we should give Melissa some time first before we go on. Is he ready?
Thomas, can you hear us? He's not in the queue, so. Well, let's take that to the end of the meeting, maybe.
Okay. All right.
And then Manisha?
That's what I thought. So I thought, wasn't sure if you wanted Militia now or. He's not out there.
Manisha, can you hear us? Well.
Diego, you want to?
He's not in the queue.
He's not in the queue. You don't know where it is.
Oh, here he comes. Look, he's a blue Pac-Man, blue ghost. It's all yours. Do I need to push the buttons for him?
Yes, if you could, that would be great.
Yeah.
Can you hear me, by the way?
Yes, you're on.
Okay, I can't see the slides. Let me just.
You cannot see the slides?
Not at the moment.
Did you download the full PDF? Because the slides are numbered, so I can echo the number that I'm presenting. Well, if you have your slides, your own original slides in front of you, we'll do +1. Okay.
Okay.
So right now it's
Okay.
title slide, and now it's status.
Okay, just give me a second to pull up the slides. I'm sorry. All right. Yeah, so I have the slides in front of me. Can you confirm that you hear me well?
Yes, we do. And the current slide on the board is status.
Okay. So good morning, everyone. My name is Militia Vucinic from Inria. I'll be presenting the minimal security draft, which is the one-touch draft, the one-touch scenario draft, which means that our main assumption is that the pledge has been pre-configured with a locally relevant credential, such as a PSK or a certificate. The 0.2 version of the draft has been published on the March 12th. And it included some major editorial restructure in order to make the text clearer and also to explicit more the asymmetric key variant of the protocol. The next step is to stabilize the proxy mechanism, as you will see, as you could hear from the Michael's presentation. And the goal of this presentation is to seek the reviews in order to further progress the draft. Next slide, please. So as Michael said,
process overview. Is that the one?
Joint process. Yeah, that's fine. Just for a recap, for those that are not familiar with the protocol, this is the overview of the join process, of the overall join process. Basically, the pledge sits and waits for enhanced beacons in order to synchronize with the network. Once it hears an enhanced beacon, it proceeds to the bootstrapping of the IP layer by performing a neighbor discovery exchange with the join proxy. And this here refers to a single NSNA exchange with the join proxy, and is, by the way, unprotected at this point. The next step is the security handshake, and as Michael mentioned, we use ad hoc, which is basically elliptic curve Diffie-Hellman over COSY, and that can be transported within the co-op payload. The security handshake is optional, and it depends on the credential that the pledge has been pre-configured with. The next step is the simple join protocol, and this is new in the latest version of the draft. Basically, we wrapped the join request, the join response exchange, and the simple join protocol in order to be able to refer to it in a simpler way. The exchanges of the simple join protocol are protected by either a PSK, by a key derived from a PSK, or by a key derived from the secret from the generated by the run of the ad hoc. Next slide, please.
Security handshake.
So here you can see some details of the current version of the draft of the security handshake. I have to say that this is still under discussion, and this is not set in stone, the way who initiates the handshake. And in the current version, the pledge sends a short discovery message, co-op discovery message to the JRC. And at that point, the JRC has two options. It can either respond with an optional ACK, separate co-op response, signaling to the pledge to sit and wait, or it can directly initiate the handshake. I see someone at the mic. Is there a question?
Yes. Could you go back to the previous slide?
So we go back to the joint process overview.
So Melissa, in this security handshake, you suggest that
yes,
one could use ad hoc. So how would you do ad hoc with PSK or with certificates? Because then you say if we don't use the security handshake and we run the join process directly, we anyways rely on a PSK. So then why run ad hoc at all if you are relying on PSK?
So the assumption of the draft is that basically the credential can be either a PSK or a certificate. Okay. So in case
so
of certificate,
then you run ad hoc only if you have a certificate. Why run ad hoc if you have
yes,
a PSK? Is it for
that's
perfect
correct.
accuracy, or what's the reason?
Yes, that's correct. That's correct. In case of PSKs, it is optional. So one can run it for perfect forward secrecy, and in case of certificates, it's obviously obligatory to run the handshake.
Okay, I need to think this through more, but sure, go ahead.
Did you state your name?
Mohit.
I think the point is that 3A is optional. Sorry, 3A is used when it's not a PSK. Otherwise, you go straight to 4.
Yes. Could you? Should I proceed?
So do you want to go back to security handshake, or are you done with that slide?
So yeah, this is what it's explained basically. This is that the security handshake is optional with PSKs, and it's mandatory with asymmetric keys, meaning with certificates or all public keys. Could you go to the simple join protocol slide, Pascal?
Yes, we are.
All right. So basically what you can see here is the simple one round trip exchange simple join protocol that refers to a simple join request, join response exchange. It can be run directly with PSKs, meaning that the key that is used to protect this protocol is derived from a PSK, and it is preceded by a security handshake in case of asymmetric keys. Next slide. So this is what Michael introduced briefly in his introduction, operation of join proxy. And in the adopted version of the draft, the joint proxy operated as a co-op proxy. And the problem there is that the co-op proxy by default keeps some state that leads to denial of service attacks with many pledges due to the limited memory of constrained devices and of the joint proxy. Initially, how we solved this is we overloaded the context identifier of OSCOAP to carry the state information between the client and the server, and the proxy was able to sniff on it in order to extract the state. There was a problem with this solution when it comes to transport of the ad hoc messages. So in the latest version, what we introduced is a new co-op option that carries state between proxy and the server. And the details about the co-op option are in the draft. What I will explain here is just basically how the operation of the option between the client and the server via proxy. And basically, client makes a request to the proxy. Proxy forwards the request, and it just adds the stateless proxy option, including as the value of the option the state information that it needs to keep internally. And the server just needs to echo this back in the response. Now, there are some pitfalls with this when it comes to separate responses, and there is some ongoing work on that, and we are trying to stabilize. As an alternative, next slide, please, Pascal.
Yes.
As an alternative to this mechanism, there is the IPA in IPM encapsulation, but the problem there is that in case of non-storing ripple, that is a must in minimal, IP in IP encapsulation results in 3 IP headers downwards. And now the question to the working group is, can all 3 headers be compressed by how much? And whether this, which of the two we would prefer to adopt and to make a mandatory to implement. So I don't know, maybe now is the good time for discussion about the joint proxy operation.
I suggest we make the exercise of the mailing list. So if you just provide an example frame, and we'll run 6-law RH over it, and we'll see how much gain we get. The real problem is, do we get the same prefix for all the addresses, things like that? So if everybody belongs to the same prefix as the root, then we can really compress stuff. So just give us a number of realistic examples, and we'll see what we get.
Okay.
Carsten Bormann, could you possibly present the stateless proxy option in the core meeting on Friday?
Oh, yes, I could. If there is time on the agenda, I could.
Well, there's a little bit of time on the agenda for new things, so we could discuss this in the core working group. I think that would be
Friday morning, 9?
Friday 11:50 to 13:20.
I can't do it, but maybe Melissa can.
Okay. So let's try to do this offline.
Okay, but please, Marisha, take an action item to provide some frames, not just fields, and then we'll compress them and we'll make the exercise of seeing how much we get.
Mm-hmm.
Hopefully we can recompress and then we can really do IP/IP, which would be good.
All right. Next slide.
So MISC update.
Yes, so this is just a slide summarizing other updates that we did on the document. It's, as I mentioned, we did a major editorial restructure, tracking of ad hoc and OSCOAP due to the changes in those drafts. We extended the joint response structure in order to include the least time for short optional least time for short addresses and 15.4 security parameters, as there were some points brought up on the mailing list about that. We added some additional sections, and particularly a section on rekeying, where we made the rekeying out of scope, but as a disclosure, it can be done with a simple joint protocol exchange initiated by the pledge. Now, I had an idea while preparing this presentation on... Yes?
Marisha, we have a question. Thomas would like to speak as well.
Oh, I can't see him because Marisha.
Yeah,
Yeah,
can you hear me?
Yes, Thomas, I'm sorry, I could not see you on the queue because I guess
That's
Melissa
fine.
didn't-
That's fine. Lorenzo just said, I mean, I can bypass everything and just appear. But so Lorenzo asked me to bypass because there's no way of removing Malisha and adding me. So one point about IP/IP versus CoAP, if I understand correctly, and I know we're going to discuss this on the mailing list, but it's not just about how much you can compress things. I think we can do magic and compress stuff and you know, one thing as well is that with CoAP, it gives us the opportunity to use 6LoWPAN well-known context, CoAP well-known resources, so that we don't have to propagate a bunch of addresses back down into the LLN, because as I understand the IP and IP and IP encapsulation, if I understand correctly, you need to have the global address of the JRC, the local address of the JRC, the global address of the LBR, all pushed down so that every joint proxy knows those addresses. And you know, just to make clear that it's not just
No,
an
I don't
exercise.
think we have to do all that. I don't think we have to do all that. Yeah.
Okay. Great. Let's have the discussion then. Thank you.
Okay, so Malisha, we need to give you back the ball.
Yes.
You are there, Malisha. We are still on MISC update.
MISC updates. Yes, so I was saying that I had an idea about rekeying, that we could just use the CoAP observe option with initial join request for rekeying, and I think that would work fine with the join request, basically. So this is something that we can discuss offline as well, on the list as well. And yes, we aligned the draft with the latest changes to the minimal draft in terms of the security layer 2 security requirements. Next slide.
Nonce generation.
Yes, so this is the slide summarizing how nonce gets generated in OS CoAP. So this procedure is specific to OS CoAP, and what our draft does is it initializes these input parameters on the top. And I just included this for completeness. I presented this also in Seoul. And basically, what gets juggled through the key derivation function is the pre-shared key, label IV, algorithm ID. And please pay attention to the last box, which is the sender ID. That includes the EUY64 of the pledge concatenated with byte string 00. Next slide, please.
A GRC.
At the JRC side, the only thing that changes is the string 01, and we keep the EUY64 of the pledge as the recipient ID of JRC, which is a bit convoluted, but is necessary in order to keep the nonce unique in case of a group of nodes sharing the PSK in the response. Next slide, please.
Pledge.
Key generation of pledge. So basically, this is quite similar. This is just here for completeness in order to summarize how the key is derived for key for sending, and then for next slide for receiving. And next slide, please.
Conclusion.
Sorry.
Oh, sorry, we have a question.
Could you go back a couple of slides?
Yeah, sorry, they're not numbered.
Yeah. So, Mohit.
So we are on nonce generation at JRC.
In this nonce generation, like which values provide you the entropy? Like
the
nonce
PSK
should be random. So. But PSK is already shared. Like it's a pre-shared key. It's shared, so it's not like random. There is other nodes in the network that know this key. At least one other, probably more, but at least one other. So which are providing you? Why not just generate like a random byte sequence and use that as a nonce?
So this is what this is the intention. So we are basically not generating the nonce. We are using the OS CoAP mechanism. So this is the OS CoAP mechanism, not our draft. What we do is we just instantiate these values set to the top.
Yes,
Okay, I will check with the OSCOAP authors then.
Okay, so back to conclusion, Marisha. And do you want to proceed on that question more on the mailing list or?
Yes, that would be great. That would be great if. And as a conclusion, just the PSK variant is quite stable, and I will be proceeding to implementation of the PSK variant. Asymmetric key is under discussion, specifically on who and how initiates the handshake. Proxy operation, as we could see, is under discussion, and we are seeking reviews to progress the draft. Thank you. That
Okay.
would be all from me.
Thank you, Marisha. Do we have any more questions? And I'm interested in the follow-up of this discussion about the norms not being passed over the air, because my memory is that the LoRa security works like that as well. So if there is a big issue, yeah, I want to know. And so next, it's not you yet, right? Yeah. Your two slots? Oh, you're doing the announcement. Yes. Okay.
Thank you.
It was you, Michael.
Yeah. Oh, change it. Okay. Okay. I'm Diego Duhovne. I will present the draft for the joinings Hans Beacon, which was authored mainly, but Michael. Okay. So this draft is aimed to add some joining information. Okay, that would be better to put it in an enhanced beacon that to make more efficient the joining process. So the thing is how much the news over there says how much information shall we put also on this enhanced beacon. So let's go. The packet looks the fields look like this. So first of all, the field there they ask for if this device is going to behave as a joint proxy. So they are informing that within the enhanced beacon, and that will they simplify the process. So they listen this enhanced beacons once within the time slot, which will be faster. Then the other bit will set the network if you want the pledges where there are the different nodes we are willing to join to initiate if they can initiate or not within this host. And the next bit if they accept the route to solicitation, okay, and route to advertisement exchanges, but are the only ones, even not only when they are host type devices. And then mostly the network ID, which will be based on the ID from the MAC layer, okay, as a hash, which is proposed on the draft. What else then? Okay, so this is an explanation of what I was describing. The thing is we are willing to reduce the overload at the joining process. Okay, and this should be more efficient if using the enhanced beacon to send this information. So that's the description, and maybe the I flag could be eliminated. We propose to use this flag. And finally, what else can we put over there? Meaning that if there are many other items that may happen to be practical to put there, but we may take care that the information there is not encrypted. So we shouldn't be sending much information that will be enhance the possibilities for attackers to know what you are doing there or not where. So a PIO shouldn't be there. And yes, okay. Go on, please.
Eric Nordmark. So it wasn't clear to me what this network ID was. You said MAC layer. Is it a MAC address? What is it?
I said the
16 byte.
So it's intended to be a hash
yeah.
of the DODAG ID.
Mhm.
Although Pascal has suggested that may be wrong as well. So Ripple passes the DODAG ID as a constant value, which is essentially the address, the v6 address of the root. And that's relatively stable throughout the whole network. And so a hash of it, which would avoid revealing it, would still be constant between the time that you joined yesterday and then looked for the network today.
So all you care about is detecting that you didn't move to another network.
That, well, you may have physically moved, but you,
Yeah, yeah.
you are finding the same network you
Attaching to
did
the same
before.
network,
Yeah. And you don't want to use the PIO because that would reveal the information.
Yes.
We thought about the hash of the prefix. Okay.
Yes.
But that seemed silly. Might as well just use the DODAG ID per tench.
And we don't care about noticing that this whole network moved from, say, Korea to this building, and it has the same ID as it had in Korea.
If the nodes, if all of the nodes, when you take them out of the box, should quickly rejoin the same network, then that would be a feature.
Sure.
Right.
But you can now tell that the IETF moved, right? But yes. Well, the privacy concerns about seeing the whole network move, right?
Right, right. So that is an issue, and so any ID we use that you can find quickly will also reveal
Have
that
that
the
property,
network
yes.
is the
Understood.
same network. Yes.
No. Okay.
Melissa asked, why is PAN ID not enough?
I
Yes.
think
That was
I think the answer is that we might decide that we're always using a constant PAN ID across all of 6TISCH. That might be an answer. Another answer is maybe it is enough.
well, why not a combination of both?
But it's not coordinated, right? So, so now
Pascal?
what are the PAN ID is a manual selection.
Thomas wants to speak.
Okay.
Yeah.
Thomas.
He said that you can give him the floor.
Push.
I was thinking.
We got rid of him now.
Oh, well, I pushed it once, you appeared, Thomas, but did not come up, and then I pushed it again. So please come.
Yeah.
Well,
Yeah.
No, we can't hear you.
I
We still
don't
can't
need
hear
to.
you.
Okay, sorry. I was
Okay,
going.
okay.
Can you hear me? Yeah, I was muted on here. So I was going to ask the same question about PAN ID. If we want to discriminate in the air EBs coming from network A and network B, PAN ID might be the simplest way. What we also discussed in the security discussions a long time ago is that we can set a private K1 in case K1 is configured and you want to discriminate different networks, you can pre-provision the nodes with a different K1. Yeah. And that would be link layer. That wouldn't be, higher up.
Yeah, so with the scanning code, slide number 3, a quick question for slide number 3. How do you identify JCE?
The JC how does the pledge know the address of the JCE?
No, the bits, the 3 bits are used for proxy, for pledge and the router nodes, right?
So-
Not the JCE, right?
So this is the join proxy.
Yeah.
Announcing if this is from a join proxy,
Yeah.
then he would have set the bit in his beacon to say I am a join proxy. He might not be a join proxy. He might just be announcing a beacon.
Correct.
Right.
Yeah.
And if he is a join proxy, then his address is his L2 address.
Okay.
Okay. So it's a link local plus L2 address.
Okay, so it does not need to know, but if the pledge is able to reach to JCE, right? Is there any indication it will get that it can, this is the enhanced beacon coming from the JCE?
If the JCE is announcing,
Reachable, yeah.
oh, so you're saying, so the JCE should always essentially run a virtual join proxy that does nothing, right?
Yeah,
That just
because physically, right, in the RF, one pledge can be reachable to the JCE as well, right?
yes. In which case the JRC should simply
Exactly.
simply say, I am also a joint proxy,
Correct.
right?
Exactly. Yeah.
Yeah.
Once you're on the bit over there, yeah.
Benjamin Dan. So I'm not sure if IEEE already handled this, but kind of a problem we have is that you can listen to beacons, but that doesn't necessarily mean you know what the right channel schedule or channel selection is to transmit on, i.e. Country code. So if you have a node that's moving around, from Korea to North America, it should have a different selection of channels based on the country that it's in.
Isn't that in the schedule part of the IE?
Well,
In minimal?
you will have a minimum schedule with
Yeah.
which channel to
Yeah.
use, right?
But
But if you go from Europe to the US, you won't even know that you need to listen to a different band if you're in the sub-gig, for instance.
Sorry, maybe it's better on the list. I can.
So are you are you talking about the regional?
Yeah,
setting?
so with this impact, correct me. I think it's a regulatory, right? Because the frequency and the channels are in the different regions are different, right? So if it comes to US, for example, from Europe, it has to operate within that band. Otherwise, it cannot operate, right?
Yeah.
Yeah, but the device may not know what country it's in when it wakes up. Okay.
Problem with the IETF.
That's IEEE.
Okay.
Huh?
That's IEEE, I think. But
Well, but we have to solve it or not solve it.
We can't solve it here.
Yeah, we can't solve it.
okay.
Okay.
Well, yes. Let's go back to the last one. Okay. So if you agree on you think this could be adopted on the group, okay. Any comments about that?
So maybe we can have a quick poll just to assert interest in the room. Like people, if you think that this work should at some point be adopted in this working group, that's of interest for this working group, please raise your hand. Well, there are a few people. Okay, if you think that working on exposing this information in the beacon should not be done in this group, please raise your hand. Well, it's just that people have not thought too much about it, so it's not conclusive for now.
Mailing list?
Yes, we need. How many people have read this draft? Yes, it's not mature yet, so
Okay.
we need more interest. And so personally, I think this is very important work for us. We really need this information to be seen in the beacon somehow. Either we do it here or we find another place for it. But that's really needed to boost the way we do this join. And so please, I urge you, go ahead and look at what this work is about and read the draft.
Samita Chakrabarti, I just wonder, I have a quick clarification question for Diego. I don't know if you have time, otherwise I can ask offline.
Okay, yes.
So the previous slide you have, where you have 3 bits in that diagram. Yeah. So the I bit, it says set if network wants pledges to initiate the join process. So does it assume that in the layer 2 communication, in the attach part, you are going to get that information? How does it know that network wants the pledge to initiate the join process?
Well, the thing is, it allows the other node to start the joining process. If not, you're not receiving any pledges to join queue with you, to start the joining process with you. That's an ability from the node itself, from the hosting, and you're not taking.
So it's pre-configured.
Yeah.
Okay, and we need to move on. We are 15 minutes late, so we'll have to shorten a little bit the next slots.
Samita, I think I can answer your question on the list. So I'm going to do this as quickly as I can. So one of the things we removed out of both 6TISCH minimal and zero touch is rekeying. Okay, so there are possibly some networks given 5 byte ASNs that will actually never ever want to rekey at the data rates because it'll take hundreds of years for them to ever run out of keys. On the other hand, rekeying is the only way of getting rid of nodes that malicious nodes or nodes that you don't like. So rekeying may be very important, not for the reasons of running out of entropy, but for the reasons of getting rid of nodes that are questionable in your network. So we moved it out of this. and new is just created. There's nothing to say about it. So basically, the idea is that we create a management interface using Comey. We create 255 entries, one for each of the key mode ID, key mode, sec mode. Pat, you'll shout at me when I get it wrong, so maybe it's written on my slides. We're using sec mode 1, right? And that gives us 255 key IDs. And essentially, if you speak IPsec, that's like SPI numbers. But basically, that's how many simultaneous keys we can have in the network. And so basically, we expose this as a management array. Here are 255 slots that the manager can update. So basically, that means you can provision new keys into it. And the idea is that you keep using the key that you have. So if it's key number 12, you keep using key number 12, and management may use the network to provision for you key number 13. And as soon as you start seeing traffic encrypted with key number 13, you start transmitting with key number 13. So that essentially the rekey, the signal to start using the new key is a ripple across the network. Go ahead.
Mohit, quick question. So the keys actually have key IDs?
Keys have key IDs on the wire. Okay. That's layer session keys, layer 2 keys. Okay. So the idea is that all we need to do is reach out to all of the nodes, tell them the new key, and then when we're ready to use the new key, we basically just we start using the new key. What this means though is that, go ahead, yeah.
So the key ID is always monotonic. You always increase it.
I'm assuming it's circular. If you go from 255, you go back to 1. I think key ID 0 is invalid. Okay, and you really only need 2 slots, right? You need to number them, but you actually only need to have memory for 2 slots in your thing. You probably don't actually have an array unless you have excess amounts of RAM. Originally, we discussed in minimal having a K1 and a K2. If we do that, then we need 2 keys for each thing. So really, we have half as many slots. And I really don't know how we've resolved that. That's just a question of, we either have 127 keys or 255. That don't care which way. So the key thing is that you have to go and reach out to every single node and tell them the new key. And potentially that takes days or weeks, depending on the sleep cycles of these nodes and whether they're reachable at all times and this kind of stuff. But that's okay, because a centralized coordinator, the JRC, has the leisure to do that probably. It probably should go and provision a new key, at some interval, days or weeks before it thinks it needs to use it. And then it can transition to it quickly. On the other hand, if you suddenly discover that you have a malicious node on your network, it can take a while before you can get rid of it, because you do have this window where everyone's going to continue to accept keys under the traffic under the old key. And there's not really a lot of solutions to that, given that we have nodes that sleep for long times and very little network bandwidth to play with. Carrie.
Carrie Lynn. Is there a corresponding requirement for clients in the network to wake up every N days so that they are able to, catch new keys when they come along?
So Taro has pointed out that if you don't wake up every now and then, you fall off of the slot frame numbers anyway. And so if that happens, you would have to join the network again as a new node, or a somewhat not so new node. So effectively, if you don't wake up every now and then, you will lose synchronization and lose the keys as well. So effectively, we're not putting a big, huge requirement on them being up. But yeah, it would be convenient if they woke up once every 2 days or something like that. And it would be nice if the JRC sort of knew what their global sleep schedule was, so it could actually reach out to them at the time that they're going to be awake, right? And that's kind of an upper layer problem from our point of view. And so if there's no other questions, I'm going to cut it short because we're running over time. So I am interested in adopting this. My proposal is to use Comey. I would love to have a Comey expert as a co-author. There are other ways we can do it. For instance, Militia has suggested we could use an observe option in the initial join process, and that's equally good. The question of what the traffic is over the wire, Comey makes it a little bit of CBOR, and the observe option would make it a slightly different bit of CBOR. So which way is kind of one way or the other. If you think that Comey is a useful addition to provision a whole bunch of other things, then I would prefer to go Comey. If you think it's useless and you don't want to do it for anything, then don't do that. Tell me not to do that. So I'm going to pass it back to Pascal.
Thanks, Michael. And the next presentation is probably Thomas. Thomas, are you with us?
Can you hear me?
Yes.
Okay, so I'm presenting on behalf of Xavi. Xavi is stuck behind a firewall on a meeting in Brussels. So I'm going to present the the update on the 6TOP protocol. Next slide, please.
Oh, Thomas, can you make it in 10 minutes?
Yeah, no problem. I can
You
do
have
it in 5.
15, I think. Okay.
That's totally fine. So it's a stable document. That's the good news. We published a new version on March 27th. There's a bunch. You'll see the diff is enormous, but this is mostly because we did some reordering and cleanup. The big differences, the real differences, are that we added a command for relocating cells. This means that, so to put this in context, the 6TOP protocol is a protocol that allows neighbor nodes to negotiate with one another to add and remove cells. It's kind of the cornerstone of the distributed 6TISCH scheduling. And so relocating, adding and removing cells, there is a possibility that different pairs of nodes add the same cell. And so there are collisions. And up until now, what we said is if there are collisions, you remove the cell from the current location and you add it again on a different location. What we added is a command of doing those two things at the same time. So we call that relocation. So you say that cell here in our schedule, let's both move it to some other location, and that happens in the best case in one round trip. That's one change. The second change is that, well, that's not really a change. The second change is that we renamed the status command to count command. The next, I mean, we believe it's stable. We believe it's ready, and we might start considering whether it's ready for last call. Next slide, please. So here just a reordering. It's just administratively changes. It's much easier to read and far less repetitions. Next, that I already talked about. Next. Okay, so the authors are asking for feedback. There's looking at this and thinking about last call. There are a number of things that so the authors have done what they everything they could. They believe the draft is ready. There's a little unknown, which is relation to SFs. SF0, SF1, SF2, can those drafts comfortably sit on top of the current 6TOP protocol draft? That's an open question. So if there's any feedback by any SF authors, please do raise them now, because the authors think it's ready. And then the second question is, are there any functionalities missing? And the way to answer this is probably to it's not probably, it's just to ask implementers to go and implement it. And since we just announced that there will be an interop event in July, the best way of getting feedback from implementers to kind of twist their arm to coming to the event and giving it then now, giving feedback then.
Thomas?
I think that's the last slide.
Thomas, what I'd like to do is find two people in this room who would be ready to make an in-depth review, and probably one of them being an expert in a scheduling function. That would be great. I'm not pointing at anyone in particular. So if you're willing to help us progress this document, and it's not a thick document, right? It's a kind of a simple process. It's more like try logic and figure out if it's working, if it doesn't have a corner case. I would be really interested in having 1, 2, 3 reviewers commit to review this document in the next month or something. So please raise your hand if you're willing to help us out here. I see Diego. Yes, good catch. Charlie, fantastic. So please write in a minute that Charlie and Diego will review this document and provide us feedback within 1 month. And yes, after that, I do expect that we'll go through the last call process. We can start the last call process even though we still have the interrupt test somehow, because we still have time. We can still do changes in that process. Also, if we are really missing some functionality, we'll do an update. Right? It's not like we can't stay forever wondering if there is not something else we could have done. So we'll update it across live. So I'm happy with
So
what it does.
as a work, Pascal, as a workgroup chair this time, I would feel very comfortable adopting, pushing this to last call if we see something running with both 6.0 protocol and SF0. I think if we don't have SF0 running and we don't have networks out there that are running this, I would feel a little bit uncomfortable, last calling it if we're not sure that all the pieces fit together perfectly.
Okay, and that's it. So next is.
That's it.
Thank you, Thomas.
Thank you.
Next, scheduling function 0. Diego again.
Yes. Okay, I'm back here.
So Diego, can you please make that fit in 10 minutes?
Hopefully. Yeah. Make my best. Okay. Well, this is the draft we have been working on for maybe 4 years, and changed names, but it's still the soul is still over there. So I thank also the co-authors who helped me for during this time. Okay, and then the idea of this draft was provide a simple, very simple distributed scheduling function according to the requirements, of course, of the 6P draft, which are being stabilized luckily. So we are working together. Okay, and this has been I think except for several small elements, okay, have been really a great job. So the last changes. So we changed final destination algorithm. We have proposed during IETF 97 3 different alternatives, and we chose the dot one, which was adopted for most from the feedback from the implementers. In fact, we fixed some typos and added some statistics without missing. Okay, and were required by 6P. So what will be next? Okay, we'd like to change to experimental RFC. Okay, and have some timeout discussion, which is the one missing element that 6P asks for. So the choice, which is a new estimation algorithm which is more realistic on what things are going on the implementation side. So we decided to have the number of a snapshot of what's going on. Okay, so we take a photo of the number of U cells. Okay, we add a fixed value. Okay, and which is a percentage. I said fixed value, not exactly fixed value, which is a percentage of the number of U cells, in fact. Okay, and then we obtain the required set, which is much simpler than we had before, because we don't have any clue of what was going on about the application, local application, or any clue about which were the reserved cells or the flows that were going through our node. So since SF0 is based on a neighbor-to-neighbor negotiation, okay, we need to establish a very simple algorithm in the middle, so that we don't know what's going on further. Okay. Then we added the packet delivery rate calculation. So we define this, and the point is that if this definition fits to what we are used to, or we can do it within a node. So as it says over there, calculated per cell, okay, as the quotient of the number of successfully delivered packets out of 10, okay, for the last 10 packet transmission attempts without counting retransmissions, meaning that they effectively the ones which were transmitted. So the question is 10 a good value for that sliding window? Okay, for the last 10. Yeah, we don't know. Okay, we need more implementation results. Okay, we are working on that, but we need others to contribute to this. And the question is, if we leave this to as implementation specific, that will generate maybe inconsistencies between 2 different implementations of SF0 on different devices. So I think we can fix an initial value or generate like exchange or a configuration between the devices. Then the timeout. So the way we got a contribution from Yasuyuki Tanaka, I think, okay, from Toshiba, and he generated a proposal in December that was really to go back to basics, in fact. So, and you can see it on the mail, okay, and there's on the slides here. He said, okay, it needs a change on 6P. That's where, because we need the 6P to manage this timeout also, because this goes back to the individual timeout for each of the transactions, and not a general timeout for the whole thing that will the SF will see. So on this side, we get there are two-step and three-step transactions. On two-step transaction, we get the start timer there, okay, and maybe the A gets a timeout when the packet is lost. Then A gets timeout also when there's no response from B, and then everything is fine. Okay, there's no timeout, and this typical thing that we can see in any other protocol. Okay, so the thing is, could this be implemented on 6P or not? That's a question before the last call. I don't know. Then on the three-step transaction, okay, the first step is similar as the two-step transaction. Sorry, and yes,
Diego?
Yes, Tom.
Did you ask the question whether this could be implemented in 6P?
Yeah.
Did I understand correctly? Because it's already there.
The timeout, the timeout value.
No, not the value, but the diagrams that you explained. What the 6P draft says is that the timeout value is left for the SF. Why? Not because we're lazy. It's because SF is the only entity in the node that has a full view over the schedule, and that can say, okay, I have that many links to my that many cells to my neighbor. I know that these are the PDRs, and so I can predict kind of how long it will take for that neighbor to answer. And then I can double that, and if it takes more than double what I expect, then I can declare that there's a problem. So the timeout calculation belongs in the SF.
Yeah, but the timeout calculation we thought about in the beginning was the full timeout, meaning the whole transaction. We don't have a view of what's going on inside 6P. So this means that we don't know if who filled the timeout, or who sends the timeout. So I think if this is the timeout we are going to specify, it's okay. But if we are thinking about the whole transaction timeout, meaning all the possible conditions that would end without timeout, we don't know. Because we have to take into account all the transactions in between to have a full timeout for the transaction. And here you are defining a timeout for each of the exchanges. And that's the difference we are talking about.
So do I understand that you're really talking about the service interface between the scheduling function layer and the 6-step layer? That this interface is not fully refined?
But we don't have specifically, okay. We cannot configure 6P. We're not talking about that.
No, but you could tell 6P, you can wait for that match, for that request, and you time out, right?
Yeah.
But that service layer, that service interface must be defined.
Yeah. Yes, but the thing is here, what we are expecting to do is that to define the timeout per exchange. Because not you have to calculate the worst timeout between all the possible exchanges, and it was very, very long. So in this case, we are just proposing to define the timeout per each of the exchanges. So it will be easier to also simpler to calculate and shorten.
Okay, let's take that to the mailing list.
Okay, that's the idea. Yeah. So thank you. And then once the explanation of what happens on the third case. Well, finally, we eliminated the term effectively because I just want to put an accent of what we really used Excel, so because it was too much, and added following some on suggestion from Randy and Yasuyuki also on the mailing list. And there's a section which is called force deletion, that what happens when the schedule is full. And the thing, what to do in that condition, okay? And then we say, okay, this may be implementation specific, which is too complex to handle directly on an SF that's trying to be simple. Finally, we have a couple of minutes. No, yeah, yeah. We define the packet delivery rate threshold, okay, as a percentage of the average of the PDR of the rest of scheduled cells. So we may have a very bad a PDR on the whole thing, okay, on the whole network. So we will say, okay, if you have a cell which is behaving worse, okay, there we have to put an alarm there, okay, and blacklist that cell, for example. But the thing is, those cells that go out of the average, that's the threshold we are using there. And another idea is that SFC relocates each of the cells to a number of available cells, and we are going to select them randomly, okay, from all the available cells. We are not putting any other criteria there. And finally, that is the PDR, the value of the PDR threshold is out of scope of the document. It's not, it becomes implementation dependent. Finally, okay, so the question is, do you agree that this threshold should be implementation dependent or implementation specific, meaning that we can define a value there as we define for the PDR value itself? And again, we did so many things as implementation specific. What will be the specific values that either we leave it like this, either we put some results from simulation and from different use cases that you may find. You have a question, Thomas? No?
Yeah, I'm trying to think about your PDR threshold question. If we leave it implementation specific, I think we need to be careful to close all the all the loose ends so that we guarantee interoperability. I think that's the only real goal, right? So can you comment, if I have my implementation, you have yours, and we bring the two devices together, is there a risk of non-interoperability if we chose a different value?
Well, from my point of view, you have a different threshold. Okay, then I'll be more nervous. Okay, or I will be more sensible to those cells that will be behaving worse than you. Then I will ask more frequently to change the cells or to blacklist them. But as far as I know, the only thing that will do the other end of the scheduling function is to allow that to change. It's not another problem. Okay, so some of the nodes will be changing cells more frequently than the others. I don't know if
but I can run a 100-node network where 50 are my nodes and 50 are your nodes.
Yeah. Okay.
That's important.
Okay, you can do it. Okay, but the thing is, what other scenarios will have there? I don't know. Yeah.
No, I mean, I'm just asking, as a chair, I just want to know if we leave this implementation specific, then we need to make sure that two implementations coming together in one network still interoperate. That's the reason for my question.
I think that will be interpreted.
Yeah, there's probably no direct impact. They can talk, right? But this value impacts the behavior of the device with all the other device, its peers, and the transport endpoints. And so if we have some consideration, for instance, on the impact of this value to a transport, I know we are not using TCP, but if you have a transport like TCP and the bandwidth is fluctuating with in a fashion that depends on that value, that should be written somewhere. So it's not just the way this device talks to the next device. They will interoperate because that's for local computation, but it will impact the way resources are consumed in the air, the way the packets are transported across this device, and it might not be symmetrical anymore for one direction, the other direction, etc. So maybe we could have a consideration statement saying our best understanding of the impact of this value.
Yeah. Okay. So the thing is, for example, that one node will be blacklisting some cells that other nodes are not blacklisting. So you don't trust some cells because the PDR for you is very bad, but for other nodes it's not. So the thing is that some of them are going to use those cells and because they consider it right or not. Okay, that will be a difference.
Yeah. But to Pascal's points, I think it's important to have a section in the draft that explains what the impact is on interoperability of making this implementation specific.
Okay.
Excuse me. Tengfei
Tengfei is in the queue.
is in the queue. Okay. So let me, Thomas, can you leave the queue so I can let Tengfei join?
Yeah, go ahead. I think Lorenzo told me that's fine. Can you try? Otherwise, I'll leave. Does it not
Press the
work?
button, nothing happens. You probably
Okay,
need to
I'll
leave
leave.
first. So we'll take Tengfei and then we'll take you.
There.
Tengfei, there you are. Oh, it's gone. Ask again, Tengfei, please. Okay, so
Okay, it's not coming back. Yeah.
please come and Tengfei will come back. Oh, okay, Tengfei is back. So let me press the button once
Okay.
and
still.
not again.
Hear me?
And there's some delayed magic. Come in, Tengfei.
Yeah, you hear me?
Yeah.
We can hear you, but we cannot see you. That's okay. Well, not
It's
really
difficult
okay.
to hear you.
We could almost hear you, Tengfei, but no more.
Okay. Now I have the comments on the PDR's ratio setting. I think because we have a different scheduling function and all the cells they are scheduled by different scheduling function as long as the cell is provisioned by
Tengfei, I don't know what your mic is. I'm sorry, but we really don't understand what you're saying.
Can you write the question on the Jabra, please? Maybe.
Or
easier.
the chat, whatever. Yeah, because we really cannot hear you.
It's not really a question, but a comment.
Okay, Tengfei, in the meantime, we'll take the other question because now we are running out.
Okay.
Hello,
Okay.
my name is Mohammed. I have a generic question. Which is
What's your affiliation, please?
My name is Mohammed.
And your affiliation?
I am from Bournemouth University, UK. So I have a generic question, maybe it's related to your draft. Like, are we considering duty cycle mechanisms for energy saving for these in 6TISCH? Like, are we considering those things? Because if we are viewing them in context of Internet of Things, and while we are using duty cycle mechanisms, so maybe nodes gets off, they are not available for the whole time.
Well, this 6TISCH is mostly TDMA in that way. So we are and the node is turned on whenever it has to transmit or receive. In fact, so we are in some way considering it. Yeah. So and it takes the time between one test on first and test on the next time. Okay, so this timeout will define the exchange in that moment for when asking for new bandwidth or letting the cells for bandwidth.
Like for IoTs, we have a condition like node should be active all the time. So I am asking the question in that context.
I think I didn't get your last question. Sorry. Can you repeat it?
Like in IoTs, we are considering like node should be active for all the time. So while we are using duty cycle mechanisms, how we are managing this thing, or is it optional duty cycle mechanism for 6TISCH?
Yeah, but I think duty cycle on transmission and reception side. Okay, this is the TDMA. It's already taken into account, but at TSH level.
So Mohammed, the TSCH link layer gives us duty cycle. I suggest that you ask the question on the mailing list, and I'm happy to answer and point you to the documents.
Okay, finally.
Yes, and we'll have Tengfei's point. So Ines will read what Tengfei was telling us. It's actually not a question, it's more explanation.
For the first one, its cell is provisioned by different SFs. So as long as the cell is related by the corresponding SF, which is running on one side, there is no issue for interoperability. Right.
Okay, so could you please copy that in the minute?
Yeah.
Thanks so much.
Okay.
So next item is really what we do with these drafts. That's the same question exactly at 6 stops. So we are running late in the schedule for this draft. And first question is, do we know of implementations? Do we have actual experience of this running?
Well, we have a previous implementation we had, okay, about the when we tested this, but we the other algorithms we had before, okay, the set estimation algorithm that we had before. We had to change the estimation algorithm there and try it again.
What I think is this draft should ship at the same time as 6TOP.
Okay.
What I'm unsure of is whether it will pass as a standard track document, because we are missing experience.
Yeah.
And my suggestion would be probably that we go through the experimental track and we learn from it. And then we hopefully we make a second generation of scheduling function when we know better, we have more field experience of it.
I agree. Yeah.
Okay.
So, but that's the idea we had afterwards.
Oh, there is
But-
no, oh, no, sorry, I still,
that's the last. Okay, so the idea was to change experimental RFC. Okay, that's that. Okay. So you said it so.
Good.
Thank you.
Any other question on this draft? Okay. So I will quickly give you an update on the architecture. So part of the work that we, Pascal here, part of the work that we had intended for this round of the charter was to consider the 6TISCH tracks. So we've had a document which was actually integrated in .NET use cases, and that is also now reflected in the 6TISCH architecture. So there is a new section which is published in Architecture 11 that was discussed in our interim meetings. So the architecture was just published a month ago from this 6TISCH for .NET draft. And the changes are really mostly this insertion of text about what a track is. So a 6TISCH track is not necessarily a serial sequence of hops, like an MPLS switch path. It can be a lot more complex than that, with nodes doing replication and elimination, not necessarily at the end of the path, but also somewhere within the path. And actually it happens that 6TISCH being scheduled makes the operation of replication and elimination much easier than in the generic case of .NET. So actually we did some experimentation, so I'm taking advantage of this quick slot to show you things that we did to experiment with 6TISCH tracks. So the whole idea is a 6TISCH track can be modeled as a chord ladder as represented here. And the whole idea is to inject a packet somewhere and to get it out somewhere else in one or multiple exit points. And the whole idea is basically to progressively flood the packet across this ladder. So if it was a single serial path, it would look like that. If you want some level of redundancy, you can replicate the packet and eliminate the packet on all the bars here. You can have 3 paths in parallel or what. And in that example, I've been using arcs to actually compute my ladder. And with this, we've been doing a number of experiments with fantastic students actually that came in. And so the first thing that we did was implement a draft that we have published at BEER. And what this draft does is actually implement something that we had published for some time in the .NET design team for adding plane alternatives. And what we do there is we define a number of segments which are TSCH hops time slots. And we associate bits in a BEER header with each of those time slots, basically. And by setting the bits at the ingress, we can actually control which of the time slots are going to be used. So if you just want to use the path on the top, then you can just set the bits which correspond to that. And if you want to do replication and elimination, then you also consider the bits which are here. And you can also flood the whole network by setting all the bits. And, well, flood from left to right, right? It's a progressive flood, which basically progresses the packet to the edge. And what you get with that is, if you have any breakage, the fact that you've got this additional spatial diversity gives you still a delivery ratio that would be impaired if there is, for instance, a metallic gear that comes here, or if this device desynchronizes, etc. So we've been playing with that. First experiment says, okay, what if we use only the upper path using ARQ, doing some retries, or if we use only the lower path here, or if we use all of these hops but without any retry. And we just compare the result. So at some point in the experimentation, we actually rebooted one of those devices here. So what you see in this picture is the number of time slots that it takes from the minimum when there is no retry, one retry, two retries, to go from one edge to the other. So those packets, there are many of them. It looks like a continuous line, but it's a series of small crosses like this. What you see, there is a very dense number of packets which made it without a retry. And then some of them made one retry, some of them made two retries, etc. So you see if the distribution of packets and how long it takes them to get to the destination. And that's typical of hot potato forwarding. So when you do the same thing on wires, you actually show the TTTech type of operation compares the traditional switches doing something like that with a deterministic switch doing something like that. When you schedule every operation, you know deterministically when the packet will get through. That's exactly what we did with the third experiment, where we have a time slot for each of those copies, so there is an absolute time when the packet reaches here. There is absolutely no retry, everything is scheduled. So the benefit is we know exactly when the packet will get in. As you see, most of the packet with hot potato reach before our deterministic packet, but here it's deterministic. Okay. And then what we did next is kind of interesting. With this beer bitmap, we can actually decide, first thing, we can sort out if there is a transmission failure, because as you use a bit and transmit over the segment which corresponds to this bit, you reset the bit to 0. When you eliminate 2 copies, you earned the 2 bitmaps. The result being that if all the transmission worked across the network, the resulting bitmap is all zeros. If you have some ones in there, that means this particular link which corresponds to this bit or this particular segment failed to transfer the packet. With this, you can decide through a control loop to set the adequate packets for the hops which work and not use the extra time slot. So basically that's what we did with the control loop. So this is the number of time slots which correspond exactly to the energy that was spent to send packet across the network. If we set all the bits, and we did it sometimes, then you see that it consumes this number of time slots, which is a lot of energy. But we do that only to probe the network, figure out which links fail. And then as soon as the link is, the failure is located, then we find a path. In this case, the path had to go something like this. So you see there is 1 extra hop, or 2 extra hops actually, there's 1 extra hop here. So each time the bitmaps comes in and tell you which hops fail, then you compute a new bitmap and you go around the prime and you continue with this. And you see that most times the energy spent was the same as the lowest cost path. Question?
Carrie Lynn, and I'm wondering if you've compared this with, for example, forward error correction.
Okay. No, there is some forward error correction. The point being that what we try to ensure here, let me go back to the previous slide for a minute. What we want to protect against is not a transmission error like some interference like multipass or something. We are trying to protect, in addition to that, because TSCH is already very good at protecting against that. So we are trying to protect against a node failure or something like that. So what you see is there is a node failure here somewhere, but the overall delivery does not suffer from it. And this is just to enable a feature like you never want, for instance, to lose 4 packets in a row. You've got this control loop, and you know that the people will stop the line if they see 4 packet loss in a row. So you really want to deterministically ensure that you will never get to those 4 packets lost in a row. And so what you do is when you detect an error, you force on the same packet all the bits on, so that really secures the transmission. From there, you learn what's broken, and you apply a new path across this structure here. So that's what we did. And you see that in average, the energy is very much that of the best possible path, but sometimes, we went around the probe. As you see, the latency doesn't change. The loss is actually increased because we don't have the full energy spending of using all the time slots compared to the green line here. So you see the full replication consumes like 2.5 more energy, but has a better delivery ratio. Here we still have quite a good delivery ratio, but the most important thing is we never lose 4 packets in a row. And last but not least, what we've been playing with again on the 6TISCH track, and that's still valid within the 6TISCH model, is to say, oh, by the way, I'm using a radio. So, okay, my radio is lossy, but it has also this multicast property that we could use to balance the fact that it's lossy to get something kind of, to balance this bad quality with a good quality. So what we did is we scheduled time slots where there would be 1 sender, but possibly 2 receivers or more, right? So we make sure that the packet progresses, but much faster than before, because now this node A has 2 chances to get this copy with time slot 1 and time slot 2, at the same time as B gets the copy for time slot 2. And then there will be a time slot 3, which is not only heard by A, but also by C. So you see that we kind of progress the packet as a wave across multiple hops. So it's kind of a form of a virtual node to virtual node to virtual node. You can see it in a number of fashions. But what we are doing here really is having more than 1 receiver for each sender, which is another way to still save a little bit of energy. So we'll see next slide. We save a bit, not a lot of energy, but we add a lot of reliability. Again, we are fighting against this possibility that a node fails, which would cause more than 4 packets lost in a row. And so I'm sorry it's more, but so what we used for this particular operation is we used REPL. So this guy was a REPL root, and this guy was a child, and basically with non-storing mode, you expose your parents to the root. So the root would compute that this guy has those 2 parents, and this guy also has those 2 parents. So they can be used to build this more complex structure. And with this, we did this collaboration scheme that I just described. And you see that now, as opposed to before, the schedule is much shorter than it was. Okay, so now we live in a world where, compared to before, where we had the full schedule latency, you have to wait for all the time slots to be scheduled, then you would reach here. Now you're actually much shorter in terms of latency. And if we compare, so what I call snooping here is this capability to send to 2 guys at the same time. And you see that we basically obtain, like, we save 1/3 of the overall latency by doing this snooping mechanism. In terms of energy, if you agree that sending is almost the same as a receive, then this transmission with 2 receivers cost 1.5, kind of. So if you see every time slot where a sender causes 2 receivers, that really equates to 6 of them. That equates to 3 transmission. So in terms of energy, we would be somewhere here versus the 4 replication, which is here. So you see, it's not a incredible benefit, but the benefit is now we have shortened the latency and we have maintained the chances of loss for loss in a row very low. And that's very much it. But what I wanted to insist on with this experiment is that the 6TISCH model for a track is a lot more than just a serial path, and we allow for logical operation to actually merge time slots into 1, or use 1 receive time slot and make that 2 transmit time slots, etc. Any question? Over there. Oh yes. The ThankFi actually is still in the queue. ThankFi is correctly in the queue now. Okay. So if you press ThankFi line.
Yeah, I just have a comment that we are conducting a large-scale experiment of 6P and SF0 on the IoT lab, and with a hardware node running with OpenWSN, and we will contribute the result to the group and verifying currently 6P and SF0 works.
I think he said something about an implementation and he's going to contribute it.
Fantastic. Well, please write that in the list of that.
One thing we can do as well to make sure the installation process is finished.
It's pretty hard to get to. I don't know what your mic is, ThankFi, but we have a problem with it.
I'm going to push the button and go on to Melissa.
Yes.
So I think they wrote, we're conducting large-scale experiments of 6P SF0 and SF0 on the IoT lab with 100 nodes running open WSN. Will contribute results to the group, verifying the current 6P and SF0 works.
And I think.
Then they
no,
say that they're conducting large scale.
That's what I just said.
And we had Malisha.
Yes,
Malisha
my point is similar to tank phase. Can you hear me?
Yes. Don't move too much.
Yes, so my point is similar just to tank phase. I'm working on the 6TISCH simulator that is open source on the Bitbucket page of the working group. And we are updating it to reflect the correct functioning of the different protocols, including 6PSF0 and the secure joining. And we'll also contribute the results to the group. The good news is that everything works well, and please, you're welcome to explore the code and to contribute further.
Okay, can you please write a few words on that as well on the mailing list, because there are people in the room and then others may be interested. So please
write
that. Okay. Thank you, Manisha. So Pat, you're next.
Good morning. I'm Pat Kinney, Kinney Consulting, and I'm going to give you an update on 802.15.4 and related standards. As you can see there, 15.9, 15.10, and 15.12 are related to 15.4. Next slide. Oh, here and just like that. Okay, there we go.
There's a laser.
Okay, thank you. These, when we do standards in IEEE, we have revisions, we have corrigendum, and we have amendments. Amendments add, corrigendum correct mistakes, and revisions just kind of redoes everything. So we've had, these are the approved amendments since the last revision. We have a physical layer for China medical bands, it's only 5. Then we have an ultra low power physical layer, which adds amplitude shift keying. Which is not interoperable with the other types of radios that we're using, such as the one that everybody here is talking about. They're using for 6TISCH. There is an interesting one, 4T. That's a higher rate, 2 megabit per second physical layer that is backwards interoperable with the current radio that's being used right now, the 250 kbit per second. The beauty thing of that one, though, is 8 times the data rate, which means then you can, in the same time duration as it takes to send 127 octets, you can send almost like 1200 or something like that. 1028. So that really does open up the with the new. Yes, it will. I mean, look at 802.11. Look at 802.3. What do you see? What trends do you see? So anyway, and then of course the new band in India. These are 2 amendments that are in process right now. S is the spectrum resource measurement, and that's really to help network management, okay? And then 4V is basically all these sub-gigahertz bands that either needed to be fixed or have been added, and there you can see Europe, Mexico, Brazil, Australia, and New Zealand. Okay, corrigendum. We're also doing a corrigendum. Why? Some of you might have figured out that the 64-bit MAC address transmission order specified in the latest revision is flipped in order from the earlier ones. So what we're going to do is change it back. That does affect security, by the way, if you're using that. And if that didn't affect security enough, then this would have. There is a missing value for the company identifier. Which is used in the CCM star nonce when you're using the short address. So those 2 things, if they don't shoot down security, nothing will. So we're fixing those 2 things. And estimated approval date is February of 2018. We have started a revision. Why? Every time we do at least 3 revisions, 3 amendments, we should do a revision. Well, we have 6. The typical revision period is 4 years. So every 4 years we have a revision, and that puts us right on schedule.
May 2019. Right now, we're going to roll up the 6 amendments. We're going to include the core agenda and other corrections, correct ambiguities and violations of our style guide, and then we're still talking about, is there anything else that we need to add? If there's something that you would like to see changed in the next revision, please send us an email. Just using the reflector would be great. Okay, here's a related protocol, 802.15.9, Key Management Protocol. And just as a quick summary for that, it's a recommended practice for message exchange framework using the information elements as a transfer method for the KMP diagrams. Guidelines for a bunch of KMPs such as .1, PANA, HIP. General purpose multiplexed data service, which is very helpful. And then also they had a fragmentation reassembly protocol. Any questions on the KMP? I think there's more and more groups starting to use this. Layer 2 routing. This is under, of course, as opposed to Ripple. Defines protocols that route packets in a dynamically changing network. It's a recommended practice, by the way. Extends the coverage area, supports data concatenation, which really helps efficiency. So you can concatenate packets together. And then, of course, small, medium, and large scale networks. This URL will get you to an overview if you wanted to just to see what's going on with the L2R. Any questions? Great. Oh, I don't know what they considered large scale, but a lot of those people, well, the chair was from Zigbee, so hundreds. In the thousands? Okay.
What was the question?
The question was, what is large scale? And Charlie mentioned it in the thousands.
Thank you.
Okay, moving on. 802.15.12. Now, I did a presentation on this on the 3rd of February on the conference call. And this URL will get you to the IEEE presentation on that, but you can also go back in IETF to look at that one. The purpose, one more time, is to reduce the complexity in configuring and using the 15.4 device. Remember that the 802.3 Ethernets, when you want to send a packet, there's 4 parameters in the primitive. 802.11, you want to send a packet. Well, there's 6 parameters in that primitive. 802.15.4, you want to send a packet. There's 28 parameters in that primitive. It's a lot more complex. We've also added, though, higher layer protocol identification. EtherType is one of those. Fragmentation of L3 datagrams, harmonization of L2 protocols. There's a lot of L2 protocols out there now. And then management of the 15.4 managed objects. In the old days, when it first came out, we didn't think there'd be any management for 802.15.4. We didn't contemplate going up to tens of thousands of devices. We've now come to the conclusion that we have to do managed objects. Updates since then, so configuration and network management. This is just an overview, again, showing in the light red is the .12 and the light blue is .4. We aren't changing anything in 802.15.4. So everything you see down there is in there right now. So if that, again, hits on the complexity issue. Up above, though, you will see the MMI is the multiplex MAC interface. The PDE is a protocol discrimination entity. And then we have the protocol modules. We only have 2 mandatory modules. Is this right? Okay. The pass-through is mandatory, and then the management protocols is mandatory. Okay, moving on. Okay, configuration. We've approved the concept of profiles, where a profile defines all the configuration parameters necessary for 15.4 operation. So you could have, let's say, 4 or 5 profiles defined, and you could quickly change between this profile. Let's say one is for YSUN, another one is for Thread or something of that sort. You could quickly change between these. We think that is really going to help. Oops, sorry, wrong button. Management protocol module would store and access those profiles, implement them into the device when instructed by either the higher layer app or another protocol module. Yang data module initially selected as using a format of either JSON or XML. We haven't decided yet. There is a growing consensus that a protocol such as NetConf would provide the necessary functionality in an efficient manner and giving us a full formal application programming interface, a formal API, and I think that would be very helpful. Yes.
My name is Mohammed and I'm from Bournemouth University, UK. I have a question like, do you have plan to consider 802.15.6, which claim to be matured than 15.4 in different contexts?
It's 802.15.6 is a medical body area network. The MAC is actually very, very similar to 802.15.4. I absolutely agree. But no, we haven't really considered that. No real reason other than no one's asked us to, I guess is the best way to say that. So, Carstens.
Carsten, this stuff's all done, or is it?
No. This is underway right now.
Okay, so when do you need Yang Siba to be able to use it?
We need to start right now. We need to start doing that, and I do have a slide at the. Oh, okay, that's just participation, but we do need help, and that's what I was going to just ask for. So that's a great segue into that. We do need help on the Yang modeling and all this kind of stuff, and we're going to do our best to work with anybody that would like to work with us in any manner they would like to work with us. So I'll get into that slide in just a little bit. Thank you, Carson. So appreciate that. Robert.
Bob Moskowitz, HG Consulting. Comment on 15.6. 15.6 has a limited star architecture. It has some very special isolated approaches to many things that the people who did it felt that that's the way it should be done. And so it's very closed in that regard. So trying to put 15.6 in a discussion of 15.4 is challenging at best. 15.7 is a much better discussion point than 15.6 in terms of inclusion.
The applications are totally different. 15.6 is intra-body, I mean, actually inside your body.
Inter-body with SARS concerns and everything else.
Yes. And 15.7 is communication over light waves, like your iPhone talking through the flash in the lens. So obviously, we're not going to get any light through significant light through the body.
You're right. No, but I think 15.6 is not needed to be brought up in this Supreme Result. So let's go.
Okay.
We need to move on because.
Yeah, that's a great idea. Let's not do that. Network management. Again, I mentioned network management before, but if we do NetConf, we can then leverage that. So I'm really psyched on NetConf and Yang modeling if we can do that. And then finally, participation. This is not asking, this is not begging, this is groveling. We need participation from this group. And so we're going to open it up and help whatever we can, email, conference calls, or conference attendance. The email reflector is right there. The conference calls, we haven't had a need for them, but we can set those up. And then finally, in May, Daejeon, Korea, but in July, the week before IETF in Prague, we're having it in Berlin. So it's a drive, but not a really bad drive. But this is a really bad drive, a Hilton Waikoloa Village. I recommend you don't try. But anyway, it's a great site if you've ever been there. It's not that expensive, and it's always sunny. Oh yeah, there is a volcano, but let's ignore that one. So please, if you want to talk to me, that'd be great. but we do need help from this group, really a lot of help. And anything that you can do, we'd appreciate. And I think that's it for me.
Thanks a lot, Pat. We had an extra slot, but we won't have time to present it. I'm very sorry, Lon, for this. So any other business?
Pat,
Yes,
this
I'm
is
sorry.
Sangeeta from 6TISCH Working Group. I think it would be very beneficial if you also have time to present tomorrow at 9 in the morning session at 6TISCH because
I'll be there. I'll
many
be there.
people will be
I have,
interested.
I'd like to present if there's time.
Yeah, we have time. We have
Okay.
some time. This
Thank
time.
you. I appreciate
Thanks.
that.
Where's the other blue sheet?
Did everybody sign?
Did everyone sign?
And is that all for the questions? Okay, thank you.
Thanks a lot, Pat. Thanks for coming faithfully every time. So really hope you're here. Oh, thank you. Well, it's not. Eventually managed to. No.
Then I realized that
That's okay.
Yeah. Thank you, Suresh. By the way.
Hey, Michael, thanks for doing this.
I can use it so that's